Okay, so uh, I'm Loris, and I'm a developer advocate at Redis Labs. And this presentation is about modules and how to write them basically in everything except C. I will start with the introduction and talk about a language called Zig, and then after me, Gavri will tell you about how to write them in Rust. The theme of my part of the presentation is the right tool for the right job. So you should know by now what Redis modules are, but to bring everybody up to speed, you can write extensions to Redis in C, and these extensions can basically add commands to Redis, and your commands can do whatever they want. You can start with adding data structures up to whatever behavior you want to add to your Redis server. One might think that modules are an alternative to Lua, but they are actually not. And again, keep in mind that you should use the right tool for the right job. And built-in commands, so like using the Redis API directly, is what you would use to do your daily stuff. It's like using a car for your daily commute. If you need to do more complex stuff, then you should use Lua scripts, which is more like an airplane. You would not want to have to hop on an airplane to do your daily commute. But for example, if you need to do stuff like your query has some logic that depends on the current state of the data in Redis, and normally what you would have to do, like if you were using only built-in commands, you would have to move the data from Redis to your client, do the computation, and then apply the changes. But with Lua scripts, you do the opposite. You bring the logic to Redis, and you reduce latency, and makes concurrency much easier that way, for example. Modules, they are more like rocket ships. So if an airplane is good to go to another country, like you would not enroll to a space program if you just wanted to move to another country. That's what I want to say. And with modules, you can add even more custom behavior. But at the same time, one thing that I would like to note is that even though these are three different scopes, not every module has to be huge and complicated and do crazy stuff. You've been seeing modules from Redis Labs, like Redis Search and Redis Graph, and there are very complex modules that do a lot of interesting things. But there are many smaller modules that do small things that are interesting and that you can build. You don't need to be an expert to do so. The way Redis modules work and interact with Redis is basically that once you compile your module, you create a shared object file, and Redis can then load this shared object file. And inside of it, you need basically to provide the implementation to two functions. One is Redis module onload, and the other is your amazing command. The Redis module onload function is basically, we could say, the main the entry point to your module is the one function that Redis will call when loading your module, and it's supposed to do like the initial setup and stuff like that, while your amazing command does whatever you want it to do. Inside your command, then you can use Redis module call or other functions to interact with the Redis ecosystem, because modules, they're not islands. They interact with the ecosystem, and they can do a lot of stuff inside of Redis. The result then is that you get a way of basically binding your function to a command string, and clients can call your command as if it were a normal command inside Redis. There is really no difference for the client. Now, I'm talking about function implementations, and in fact, there are many more details. But you don't need to know about those, because they are decided by the CABI standard. As long as you provide a CABI compatible binary, you're fine. You don't need to know anything else. And the nice thing is that you don't even need to write C to produce a CABI compatible binary. There are some reasons why you might not want to write C. I know, because I wrote a module called the Redis Cuckoo Filter before I joined Redis Labs. And my module basically implemented a probabilistic data structure called cuckoo filters. They're like Bloom filters, if you know what those are. But regardless of what my module does, I had a good experience in general. Like, Redis makes it very easy to write modules. Like, I even had a presentation at RedisConf last year, and the title was Implementing a New Data Structure for Redis as an Inexperienced C programmer. So I am an inexperienced C programmer, and I could do it. The pain points that I had, though, were a couple. First of all, no generics. You don't have generics in C. And if you want to know an interesting interview question, ask your candidates, why use generics? There are two answers to that question, and people usually only remember one of the two. The main one is that with generics, you get basically type-checked code reuse, right? You write a function, you plug in a generic parameter, and then you get a bunch of implementation for each compatible type. And that's the one that people usually remember. But there's also a second one, and it's that having different implementations for each type allows the compiler to optimize them. Usually, if you're writing like in Java or other big object-oriented languages, you don't care too much about that second aspect, the optimization aspect, because basically every single implementation of your function is just dealing with a different subclass. But it can make a difference, and it did make a difference in this case, because I was writing in C, I was dealing with hashing functions, I needed my module to be fast. I mean, I'm writing a probabilistic data structure for Redis. I'm not writing a Java firmware for a fridge, so I wanted it to work very well. I ended up using preprocessor macros, and I do not recommend it. I basically had a macro that would copy-paste slightly different versions of the same function, and it made understanding the code much, much harder. The second pain point that I had was that the build process was not immediate. Again, I'm not a C guy, and makefiles, if you're not used to reading them, they can be very confusing. Then there's the problem of cross-compilation, because I was developing on a Mac, and I wanted to deploy on Linux. And there are some small differences between compilers, and all this stuff is probably also like my fault. I don't know well enough the ecosystem. But at the same time, my point is I want to know stuff in detail as long as I get a benefit out of it. But there are some quirks in the C ecosystem that are legacy, that have been there for a long time, and I honestly don't want to deal with them. Like, it's like hand cranking, right? Nice and easy. Sure, like in the 70s maybe. In 2019, people expect to turn a key and the car should start. Like, don't do that. And I'm mainly complaining about the preprocessor because I hate that thing. So let me tell you about an alternative. There's a language called Zig. And it's a very new language. It's very, very new, very small community. And it's developed by Andrew Kelly. I hope I pronounced that correctly. And this language wants to compete directly with C. And one might say, oh, why should I bother with yet another language, which is very small? You just said it. And there's Rust, which is this big language. Everybody says that it's amazing. It's developed by Mozilla. I mean, what could be better than that? And my answer to that is that, again, it's the right tool for the right job. Rust is definitely an amazing language, but it's not the solution to every problem, at least not the easiest solution to every problem. I have two big arguments in favor of giving Zig a chance. One is that even though Rust has a lot of things, it doesn't have every possible feature, and out there are some languages that have features that you don't find in Rust. And the second is that, so basically Rust is a big idea language. Some people describe it that way. The language is built around the idea of the borrow checker, which is this thing that basically prevents you from misusing variables. Like, it can check at compile time if you are misusing variables, like if you're doing stuff like freeing and then trying to read the same memory again after. But it makes programming much more complicated, much more hard. Like, this is also common knowledge about Rust. And it's worth it. I mean, it's a very good thing. Like, when you're using the borrow checker, basically you get static garbage collection, which is an amazing idea. Like, you don't get all the downsides of dynamic garbage collection from garbage collected languages. Problem is, like, in my module, I was only allocating memory in one place when creating a new key. And then I would not have had any other need for the borrow checker. So I would basically had a harder time building in the module. I would have gotten some benefit compared to C. But the borrow checker, once you don't have to use it, it makes Rust case much weaker. Still, very strong, very good. It's a great language. Less strong once you don't have to use the borrow checker. So let's see the main features of Zig. First of all, the primary goal of Zig is to integrate very easily with C and incrementally take over. But it's not a complete rejection of the way of programming that you are used to when dealing with C. Like C, the people who keep using it, even despite the downsides, is because it also has very good features. It also has a very good design idea behind certain things. And Zig is not rejecting those. You will still do these things also while developing in Zig. It's just some corners have been rounded a little. So memory is manually managed, like in C. You can import header files from C and use the C types and functions and everything directly from Zig, and vice versa. When you compile Zig, you get an automatically generated header file, and then you can link from your C project stuff that you wrote in Zig. It's very easy. Like, if you don't tell anybody that you wrote something in Zig, they won't even know. You have different build modes. Debug, which is the safest release mode, which basically, instead of having undefined behavior, which is something that you occasionally get in C, you always get an error, so no undefined behavior. You have then release fast and release safe, and release fast is to make a very fast binary without any kind of safety check, while release safe is still faster than debug, but you have some safety checks that remain in place, stuff like checking if you're trying to go out of bound from an array. And then, while releasing in release safe mode, you can still turn off safety checks from certain code paths, so that if something needs to be as fast as possible, it will be as fast as possible, while not giving up the general safety of your program. And cross compiling with one command, which is not bad. Oops. Okay. Then, compile time reflection and code execution, no preprocessor. Yes. Compile time code execution is especially nice. You can do that in Rust, not as well. Compile time code execution in Zig is slightly more powerful, and I've seen some things implemented with compile time code execution that for Rust was done using macros, using procedural macros, which, if you don't know about those, they basically manipulate the AST of Rust in the code. Rust is not a Lisp language. It's awful to see. Can be powerful, can be good in other situations. Sometimes it's not. You also get generic data structures and functions, pretty good. And amazingly, you also get optional types instead of null pointers. So in Zig, null pointers, like if a variable is of type pointer, it cannot be null. If that thing can be null, it has to be an optional pointer, and you have to unpack it explicitly before trying to dereference it. So you don't dereference null pointers by mistake. You have to do it explicitly. And at the same time, you don't have to basically check everything regardless whether they could be not null or not, or risk leaving an error in your program. That's very good. So in general, the general idea of Zig is that it's a simple language so that you can focus on debugging your application and not your knowledge of the programming language, which is, if you ask me, is a big bar to both C++ and a little bit also to Rust. So what do you do when actually trying to write a module in Zig? Writing for C starts with importing the Redis module.h header file from the official Redis repository on GitHub. And once you import it, then, as you remember, you have to implement two functions, Redis module onload and your command, which in this case is the hello world command. With Zig, it's the exact same thing. You include the header file, and then you write your code, which is not even that different from C. It's a mixture, it's an in-between C and Rust. It's nice. The problem, though, when importing, in our case, when importing the header file directly, is that pointers in that header file could be null. Zig doesn't know if any of those pointers referred to in the header file could be null or not. So everything becomes an optional pointer, and the optional stuff is the question mark that you can see everywhere. So this Redis module, C context variable, it could be null. Same with the module string pointers, could be null. Even this thing, this is a variable that contains a function pointer. That function pointer could be null, so you have to explicitly unpack it before you can call the function. And actually, that's fair from Zig, but at the same time, we know that these things are never going to be null in normal situations. We don't know that from the file. We know because that's how Redis works. So I wrote a Redis module, the Zig file, which actually was created by using the translate C command from the Zig compiler that translates automatically the other file to Zig code. And then I just edited it slightly, removing the optional thing from a few pointers just to make it easier. And you can find it on GitHub. I suggest you start with this if you ever want to write a module in Zig. Compiling also, that's simple. To compile a module, you just use bitlib, and you have it. This produces the shared object file. You're done. If you want to cross-compile, just specify the target. You're done. Nothing else needs to be done. I want to leave you with my bet. I think that 80%, so Rust is a very strong contender for writing Redis modules. My bet is that 80% of the modules that will ever be created will not need Rust specifically. Because there will be small modules, simple, like my cuckoo filter module. They do have reasonable utility, but they don't do crazy stuff with concurrency, memory allocation. So they will have no need for the borrow checker, and so not for Rust specifically. But the remaining 20%, big modules, like Redis Search, like Redis Graph, and big ideas, for those, Redis could very well be the right tool. And I want to leave it to Gabri Philipson to talk about that 20%. Thank you very much.